Okay, in the last class, we started this feedback amplifiers. So in the feedback amplifier, first we are seeing that the definition of feedback amplifiers, basic block diagram. Okay, so and characteristics of the feedback amplifiers, right? So basically, the feedback amplifiers two types, that is negative feedback and positive feedback. So now we are discussing the negative feedback. So we are seeing that negative feedback characteristics. So that is what are the characteristics of the negative feedback? What are the characteristics of the negative feedback? Can anyone tell? Yeah, madam.
Sensitivity,
Yes. Characteristics. Characteristics of feedback amplifiers. First one is sensitivity. Second one is second one.
gain,
Gain is decreased. Okay, this is good sensitivity. Third one is bandwidth is increased. Fourth one is noise decreased. Okay, so these are the characteristics of a negative feedback, right? So negative feedback amplifiers, and then we move to the types of in the block diagram, the types of mixers and types of samplings, and the types of mixers are the two types, that is series mixer and the shunt mixer. Sampling also two types, that is current sampling and voltage sampling. Okay, and one more important point is sampling is nothing but it's a constant. It's constant. That is, suppose if you take voltage sampling, voltage always constant. If you can take current sampling, current is constant. Okay, voltage sampling means that is a shunt connection. In shunt connection only the voltage will be constant. Current sampling means it's a series connection. In series connection only current will be constant. So based on that, so input there are the two categories and output also two types. So we have the combinations of four, that is voltage series, voltage shunt, current series, current shunt. Okay, so all types of the very small deviations, small difference of between all the four feedback amplifiers. So that is what. Okay, so that is voltage series, voltage shunt, current series, current shunt. So we have seen that how to draw the block diagram and how to calculate the gains and how to calculate the impedance. This is the since till this point all are over. Now we are going to calculate output impedance of the four different types of the feedback amplifiers. Okay. Any queries from in these topics, previous topics? Please let me know. So I will repeat it again. If you have any queries, please raise your queries. Any queries?
glance.
Huh? At least if you don't have any queries, say no. So no queries like that.
no queries, sir.
Sir, please give a glance on it.
Sorry.
Sir, please give a glance on last topic.
Okay. So these are the characteristics of feedback amplifiers. So what we discussed, so we have to go on for the block diagram. So that is feedback concepts. Feedback concepts. Okay. So in this feedback concept, one basic amplifier is there. One basic amplifier. Okay. So next, this is the sampling. This is mixer. This is mixer. Okay. So this is input signal. It could be voltage or current, and depends on the type of mixer. Okay. So this is the low RL and feedback network. Feedback. Okay. So this is the basic feedback concept network. Okay, this is RS and this is XS that I don't know what is the current or voltage, and because it depends on the mixer, it will be good. So in this feedback concepts, then feedback network is always same for all the things, and only thing will be how to discuss about mixer, basic amplifier, and sampler. First, let us look at the basic amplifier. The basic, we know that there are input electrical parameters of current and voltages, and output also current and voltages. Okay, so input is two types of the electrical parameters, that is current, or it could be current or voltage. Output also it could be current or voltage. Depends on this generation of the signals. Depends on this current generation of the signals. So the basic amplifier are classified into four types. Four types. So that is, it depends. Suppose if you want to, output is current and input is current, output is voltage, input current, input voltage, like the combinations. Again, there are the two and two, so you will get the four combinations. So so first combination is, so output and input signal. So if you want output is current and input is current, and output and voltage and current, voltage and voltage. So if you take this combination, based on these combinations, we can tell that what the basic amplifier we used to use. So if you want output current, input current, and we should use in the place of the basic amplifier, that is current amplifier, we have to use current amplifier. Okay. So output is current and input is voltage, means that is trans conductance amplifier. Okay, for trans conductance only, output is current and input is voltage. For this, output is voltage and input current. So this is trans resistance amplifier, and this is finally voltage amplifier. Okay, so that is based on output signal and input signal. So output is a 2 electrical parameter, input also 2 electrical parameter. So based on that, so we can replace the basic amplifier with either current amplifier, transconductance amplifier, transresistance amplifier, voltage amplifier. Okay, so that depends on the selection. So for this current amplifier, so you can have, so current amplifier is nothing but, so in the place of basic amplifier, the signal has to generate first. Okay, for both input side and output side, the signal has to generate. So the signal has to generate and take. So input current will be generated in shunt connection both. So input is shunt, output is shunt. Okay, current amplifier, first the signal has to be generated. Then you can maintain it is constant or variable, and that is secondary. First thing is we have to generate the signal. In the basic amplifier, we are generating the signal first. So for that, the current amplifier means, so we will get current amplifier is, and this is IS. Okay, so this is what? So this is A into IL, R naught, RL, RL, and this is RS, this is IS, and this is IA, last load current. Okay, so if you compare these, this is IA current, this is IA current. Okay, so just to see the look at this, so we would like to get maximum gain. We'd like to get maximum gain. So gain, in order to get the maximum current, the load current should be high. So in order to get this is high, so the relation between R0 and RL far less than RL. R0 must be far greater than RL. So then only the current will not flow through this. It will not flow this, and it will come to this load resistance. Okay. Similarly, the II should be high. II should be high. So in order to get II maximum current, RI should be far less than RS. RI should be far less than RS. So then only the so it should be high. So the resistance should be high. So then only the current will come and flow through this direction. So this is the relation between the input impedance and output resistance. See, input impedance RA far less than RS means the feedback amplifier which uses this current amplifier, the input impedance will be less. That we can verify later. That we can verify later. So output impedance is large, input impedance is less, and output impedance is large. Similarly, if you go for the trans conductance amplifier, output is current and input is voltage. So input is voltage means we can connect in series connection, and this is series, and output is this parallel. Okay, this is RS, and this is VS, and this is RA. The voltage drop across RA is VI. Okay, so this is A into VI, R naught into RL. So, and one more thing is I told, so this A, the representation, you can have A for all common to all type of basic amplifier, but please look at define the definition. If it is current amplifier, A is equal to I naught by I. If it is voltage amplifier, A is equal to V naught by VA. If it is trans conduction, A is equal to I naught by VA. If it is trans resistance, this is V naught by VA. So the definition will be varied. So it depends on the type of the basic amplifier. Okay. For to avoid the confusion and to avoid the or otherwise in the place of the trans conductance, even you can represent with GM or AG also you can represent. If you have any confusions between all these terms, you can connect with the AG or GM or A. So the current amplifier A or AI, A or AI, and this in the trans conduction is AR or RMF, mutual resistance, like that. That is depends on your no, mode and all. So this you can represent with the A for all, or you can have some kind of the notation. That's not a problem. Okay, so in this for this the current should be high. In order to current should be high, R not far greater than RL, that we know, and the voltage should be high. The voltage should be high, and when you will get the voltage will drop will be high. That particular resistance will be high. Then only you will get maximum voltage. So RA far greater than RS. This is the relation for transconductance. Okay. So like this, we discussed that remaining the trans resistance and voltage amplifier also. Okay, like this we discussed. Okay, so these are about the basic amplifiers. And next, coming to the mixers. Mixers, there are the two types. That is series mixer, okay, and shunt mixer. Series mixer is suppose if you take RS and voltage. Okay, this is a basic amplifier. This is the series mixer. This is basic amplifier and all those things. This is the series mixer. Okay, so RS in series, okay, and shunt E is nothing but parallel resistance, and this is basic amplifier, and this is feedback. Okay, this is the voltage amplifier. Oh, sorry, that is a shunt mixer. Okay, and remember one thing: mixer is nothing but addition, okay, or change or difference. So many. So the signal will not be constant in mixer. The signal will not be constant. It may be add, it may be subtract, it may be change, difference. Okay. So the type of signal, so the signal will be changed, right? So if you take the series connection, in series connection, voltage will be variable, and whereas the current will be constant. In series connection, current will be constant, and voltage will be variable. So here the series mixer is nothing but input is voltage. Remember, if input is series connection, input voltage is voltage. If input is shunt connection, input is current. Input connection is shunt, input signal will be current. Okay, input series connection అయితే voltage ఉంటుంది, input shunt connection అయితే current ఉంటుంది. Similarly, sampling. In sampling, again there are two types, that is voltage sampling and current sampling. Voltage sampling and current sampling. So in the voltage sampling is nothing but it's constant, no change, constant. Okay, so no change. So in this constant mean voltage is constant. Voltage is constant means the output should be parallel. Okay, so this is feedback and this is parallel connection. This is parallel connection. Okay, so this is parallel connection. And the current will be constant in series connection. So this is series connection. All right. Okay, so this is series connection. This is shunt connection. Right. So voltage is nothing but shunt connection. Current is nothing but a series connection. Right. So in this now compare input is we have the two connections, output is also we have two connections. So based on this, the feedback based on this types of feedback topologies are one is voltage series feedback amplifier, voltage shunt feedback amplifier, current series feedback amplifier, current shunt feedback amplifier. Okay, so in this voltage amplifier, okay, so we can have some matching. So some basic amplifier also we have four. That is current amplifier, voltage amplifier, transconductance amplifier, trans resistance amplifier. Now tell me which one will match for voltage series feedback amplifier, which we have to connect. And remember in these topologies, the first term is the sampling output. First term indicates the sampling. Second term indicates the mixer input. Okay, sampling is output, mixer is input. Tell me. For voltage sampling, for voltage series feedback amplifier, what would be the basic amplifier?
Voltage amplifier.
Sorry. Come
Voltage
again.
amplifier.
Voltage amplifier.
Okay, voltage amplifier. The reason is sampling is constant. Voltage sampling and the output voltage. Input series is a change. I mean mixer is change. In series connection, voltage will be changed. So output voltage, input voltage. So voltage amplifier. Voltage for voltage shunt.
Trans resistance.
Yes, trans resistance. Next current series.
Transconductance.
Ohm's conductance.
Okay. Current shunt.
Current
Remaining is
current amplifier.
okay. So these are the types of basic amplifiers we have to insert in this topologies. Okay. So the next and in these topologies there are the four steps. First thing is we have to draw the block diagram. Okay. Circuit diagram we have to draw. Second we have to calculate the gain. Third, we have to calculate input impedance, and fourth, we have to calculate the output impedance. Right. So, first three steps already I told in the last class. Okay. Anyway, once again I will just repeat. Right. And then we'll go to the output impedance calculations. Okay. So, in this, before starting that, we have some table. Okay, so table is nothing but the types of the feedback, right? So that is voltage series, voltage shunt, current series, current shunt feedback amplifier, and this is signals like X naught, XF, XS, XI. A is equal to AF is equal to X naught by XS. A equal to X naught by Xi, beta equal to XF by X naught. X naught. Okay, so we have filled this table. Actually, in the last class, we have filled this table. Okay, so in this table, we can have, so what is x naught, what is xf, xa, x naught, all those things, right? So the voltage series feedback amplifier, what is x naught? X naught is the output signal. Okay, xf is the output of the feedback. Xs is the input of the feedback amplifier. Xa is the input of the basic amplifier. Okay, remember these three signals will be same type of the signal. Like suppose is voltage, and these three signals will be voltage. If input is current, these three signals will be current. Okay, so these three are the input signals, and this is the output signal. Okay, coming to the voltage series feedback amplifier, what is the output signal? What is the output signal for voltage series feedback amplifier?
Voltage.
Voltage. Here input is
VF. VI. VS.
C9, C9, C9.
Sir.
For voltage shunt feedback amplifier, what is the output signal? For voltage shunt feedback amplifier, what is the output signal? Hmm? ఏం చేస్తున్నాం మరి వినకుండా? మొన్న వచ్చా కాలేజీకి ఆఫ్లైన్ క్లాసులకు?
వచ్చాను సార్.
మరి ఏం చేయడానికి వచ్చిన మరి ఏరా
సార్
ఏం చేద్దామని వచ్చిన మరి? ఉన్నా నా క్లాసు?
ఉన్నా సార్.
మరి ఏం చేసినావు? ఏం చేసినావు?
విన్నా సార్, మర్చిపోయినా సార్, విన్నా కానీ.
ఇది మర్చిపోయినావా? నా పేరు తెలుసా నీకు?
సార్
నా పేరు
ఏంటి సార్?
Do you know my name?
ఎస్ సార్.
What's my name?
నాకు అర్థం సార్.
అది మర్చిపోలేదే.
మొన్నట్లో మర్చిపోతుంది సార్.
మరి సబ్జెక్ట్ ఎట్లా మర్చిపోతారు సార్? డైలీ ప్రాక్టీస్ చేస్తూ ఉంటారు సార్ అంతే. ఆ రోజే మీకు ఇది మర్చిపోతారు బాబు, ఈ రోజే ప్రాక్టీస్ చేయండి, తర్వాత గుర్తుండదని కూడా చెప్పండి. For voltage series feedback amplifier, so output is voltage, input is also voltages, and AF is equal to V naught by VI.
V naught by VS.
V naught by VS, and this is V naught by VI, and this is VF by V naught. For a voltage and feedback amplifier, what is the output voltage?
Current.
V naught.
Output is V naught. Input is what is input? Voltage and feedback.
IIS.
Okay, so based on this, you can fill this. Next, current series, which is I naught, VF, VS, VL. This is I naught, IF, IS, IA. Okay, so you can fill these three. Okay, so this is a plus. Please remember this table. So it helps a lot for your feature derivation part. Okay, so this very important. Only this table also need not to add anything. Only thing is they see the input connection. So based on that connection, you have to tell that electrical. If input is series connection, input signal is voltage. If input is shunt connection, input is current. Okay, coming to the output, anyway, it is there in the title itself. Voltage series, output is voltage. Current series, output is current. Voltage shunt, output is voltage. Okay, the output signal, it will be there in the title, but coming to the input signal, so that you have to take care about it. If it is series connection, input is voltage. If it is shunt connection, input is current, like that. Okay. So this is the table. So from this, you can have okay. So from this, so first let us discuss how to draw the block diagram for this what we call feedback amplifiers. Okay. So for example, if you take voltage series feedback amplifier, okay, voltage series feedback amplifier. In voltage series feedback amplifier, input basic amplifier is voltage amplifier. Voltage amplifier. So output is voltage, means shunt connection. This is voltage. This is feedback beta shunt. Output is voltage ante, so output is constant shunt connection. Input is series connection. This is series. So like this, we have to draw the voltage. Vs voltage amplifier. So this is Vi, this is V0, V0, Vf. Okay, so like this. So or elsewise, if you take what we call voltage shunt feedback amplifier, right? Voltage shunt is or some, let us take current shunt feedback amplifier. Opposite. Current shunt feedback amplifier. Current shunt feedback amplifier. So what will get? Output is current. Okay, so anyway for current shunt, this is current amplifier is input. Okay, output is current, and the output is series connection. In the series connection only, output is constant. This is beta. Okay, so input is shunt connection. So input is shunt, and so RS is parallel. Okay, this is IS, RS, II. This is I naught. Right, this is I naught. This is IF. Like this. This is okay. So this is what current shunt feedback amplifier. Output is current. Current will be constant in the series connection. Okay, like this you can draw the block diagrams of the four types of feedback amplifiers. Okay, next gain calculations. So gain calculations are is nothing but A is equal to the basic standard I told. So X naught by XS, AF is equal to. So where X naught is equal to XS is XI plus XF equal to X naught by XI divided 1 plus XF by XI, that equal to X naught by XI divided by 1 plus XF by X naught into X naught by XI. I divided and multiply with X naught. This I can write A by 1 plus A beta. Okay, this will get. Now, for these four types of the feedback amplifiers, this is the derivation is common to all. Okay, so common to all. Only thing is it depends on this table. Depends on this table. So you find out what is what we find out what is X naught, XF, XS, XI for the four different types of topologies. We just substitute rename that X naught, XS, XI, XF with the corresponding electrical parameter. Then you'll get this equation. So this is common to all. Okay, so like this you can do like this you can do for the gain calculations. Okay, so you can have do the gain calculations for this. Right. Next, coming to the input impedance and output impedances. So input impedance and output impedances. So for this, we have to draw the input impedance, input and output impedance. We have to draw the internal structure of your block diagram. Like, okay, I will draw here. I will draw. For example, if you take, okay, for example, if you take voltage series feedback amplifier, voltage feedback amplifier. So for voltage series, what is the basic amplifier? What is the basic amplifier?
Voltage amplifier.
Voltage amplifier.
Voltage amplifier.
Okay. Yes, voltage amplifier. So for voltage amplifier circuit, you recall RS or not RI. Okay. Input or not R. Okay. So this is Vs. Now, so coming to the input series, the voltage series feedback amplifier. This is a series connection. Input is series connection. So you have to connect the feedback network. So this feedback will be this feedback is connected in the connected in series now. So for RS key, VS key series to connect. Am I right? So now we have to connect one beta value here like this. So this is a internal structure of voltage series feedback amplifier. ఓకే సపోజ్ ఇన్పుట్ ఇస్ షంట్ కనెక్షన్ వోల్టేజ్ షంట్ అని అనుకోండి అప్పుడు ఏమవుతుంది ఈ ఆర్ఎస్ విల్ బి ప్యారలల్ అండ్ ఆ బీటా ఆల్సో విల్ బి ప్యారలల్ ఓకే ప్లీజ్ రిమెంబర్ వన్ పాయింట్ సో వోల్టేజ్ సిరీస్ అంటే ఇన్పుట్ సిరీస్ సేమ్ స్ట్రక్చర్ మీ వోల్టేజ్ ఆంప్లిఫైర్ స్ట్రక్చర్ సేమ్ బట్ ఓన్లీ దిస్ ఇన్పుట్ సిరీస్ కనెక్షన్ కాబట్టి ఫీడ్బ్యాక్ కనెక్షన్ ఫీడ్బ్యాక్ అవుట్పుట్ వాట్ ఎవర్ ఇట్ ఈస్ దే దట్ హ్యాస్ టు బి కనెక్టెడ్ ఇన్ ది దిస్ సో బీటా టైమ్స్ ఆఫ్ అవుట్పుట్ ఈస్ V0 సో బీటా V0 VF actually this is VF. Okay, VF and connect all output and VF should be connected here. That is like this. VF is equal to beta times of V0. So from this, you can calculate the remaining. From this, you can calculate the input impedance. For example, input impedance is RIF equal to what is the formula? Input impedance. So input is series connection, no? So I can write VS by IA. Why am I writing VS? Is input is series connection, so voltage will be varied, so voltage is Vs better. Other input shunt connection aithe we have to take it as Is. Input is shunt connection, we have to take it as Is. So okay, Vs is nothing but Va plus Vf divided by Ii. So separate Va by Ii plus Vf. Vf is nothing but a beta times of V0 by Ii. Okay, Vi is equal to beta times of V0. Okay, so that is equal to Vi by Ia plus beta. V0 is nothing but A into Vi again. Okay, so now take it Vi by A as common, so that becomes 1 plus A beta. This is Ri into 1 plus A beta. So Rif is equal to this. Okay, so this derivation is common for voltage series feedback and current series feedback. Why? Because in the both the cases, in input series connection, no, so this derivation is same. This derivation is same. So for current series feedback amplifier also, okay, input series kada. Input series ante input impedance derivation for same for voltage series and current series, right? So similarly, so we derived the previous remaining also. So remaining ante for example, okay, current shunt draw chestam. For example, current shunt ante what is the output structure? So current shunt output is current. Current shunt basic amplifier enti
Current amplifier.
current amplifier. So it recall your current amplifier basic structure. Input is current, output is current, and parallel output is also current. Okay, right? So this is the R0, RL, RL, RS, IS. So now the feedback path ekkada connect cheyali. If input is shunt kabatti ikkada parallel lo oka feedback. This is IF. IF is equal to beta times of I0. Okay, so input is shunt kabatti we have to connect in parallel. Input is series aithe ikkada series lo connect chestam. Okay, so for this RIF equal to input is shunt means we have to write V by IS. Anyway, so resistance is equal to voltage by current. That's we are not deviating that Ohm's law, but only thing is input current shunt we take the IS. Why? Because input is variable, current is the variable. So from this Vi by IS is nothing but Ia plus IF. Okay, Vi by take I as common, so 1 plus IF by Ia is equal to Vi by IA divided by 1 plus divide and multiply with output signal, that is I naught into Y naught by IA. So finally RAF equal to RA by 1 plus A beta. This is for voltage shunt, current shunt. This derivation is common for voltage shunt feedback amplifier. Input impedance. Voltage shunt is common. Two are common. Okay. So this is input impedance. Now let's come to output impedances. Now the actual topic starts here. So this whatever I discussed as of now, everything is already discussed in the last week. Okay. So now let us come to the first actual topic, that is output impedance. Okay. First, let me calculate for voltage series feedback amplifier. Okay, voltage series feedback amplifier. The structure is this. This is RL, R naught, A into VA, RA, RS, VS, and this is VA. Okay, this is the voltage series feedback amplifier. Now look, when we are calculating, so you remember one point, when output impedance is calculating, the load resistance should be disconnected and input signal should be kept constant. Okay, input signal should be kept at constant, right? Okay, so input signal kept at constant means, so what is the input signal here? The overall is so excess means it may be zero or maybe current or voltage, it should be zero. You remember this point. This is very, very important. When you are calculating output impedance, the load resistance should be connected. This load resistance should be connected from the circuit. You remove this. Next, input signal should be kept constant. What is input signal? Excess. Excess అంటే the voltage గాని current గాని ఏదైనా గాని, that you have to keep it as zero. Okay. So now, if it is removed, when it is removed, what you will get? It is removed. Okay. So the voltage is current. So the voltage is V and the current is I, let us say. Okay. So okay, I will redraw the circuit again till 2. So this is V, this is V, this is I, R naught, A, VI. Okay. Now apply KVL. V equal to, okay, I into R naught plus A, V, I. Okay, before that, so R naught F with feedback equal to capital I by capital V by capital I, capital V by capital I. Okay, V by I. So from this you can write I into R naught plus A into VA equal to, you can write VS minus VF, you can write. Am I right? Why? Because, so why? Because Xi equal to minus XF norm. So VA equal to VS minus VF. So from this I R naught plus A into minus V. Okay, why? Vs equal to 0. Because y equals 0. So V plus AVF equal to I into R naught. You send this term this side. Okay. V plus A into VF and beta times of output voltage. That is V. VF is equal to what? beta times of output voltage. So what is the output voltage now? V is the output voltage. V is the output voltage. So V equal to so that is V equal to I R naught. Take V as common, 1 plus A beta, 1 plus A beta, I into R naught. So V by I equal to R naught by 1 plus A beta. That implies V by I is nothing but R naught F equal to R naught by 1 plus A beta. Okay. So you keep so 1 second, check it, and if you have any queries, ask me now. So remember one point, when you are calculating output impedance, the load resistance should be disconnected and the input signal should be kept constant. Okay, input signal excess and the it should be 0. So then apply KVL. V is equal to I R naught plus AVI. VI is nothing but Vs minus Vf. As Vs is 0, so A into minus Vf. So you said this at V plus AVF equal to I R naught. Now V plus A into Vf is nothing but beta times of output. So beta V. So I'm taking V as output. So I R naught and take it simplified, you will get this calculation. Any queries in this? Any queries?
No, sir.
Yes. So this derivation is same copy paste for voltage shunt also. So this is for voltage series, right? This is voltage series. Output is voltage. So you are calculating output impedance. So output is voltage. So this is the derivation. The same derivation you can copy paste for voltage shunt feedback amplifier. Okay. Why? Because output is common in both the cases. In this output is voltage and this also output is voltage. Voltage series voltage shunt lo output అనేది voltage కదా. Voltage series and voltage shunt output is voltage terminal. So the same derivation you just copy paste for the voltage shunt feedback amplifier. Because both are same. Understood? So again you can redraw the circuit. Okay, so voltage will be same. Voltage will be same. So only thing is this connection will be different. So I will redraw the circuit. Voltage shunt. Voltage shunt basic amplifier into what is the basic amplifier? Voltage shunt.
Trans resistance.
Trans resistance. We call your trans resistance structure on. Okay, trans resistance. The feedback is out. What is the feedback? Will be parallel. Why? Because input is shunt connection now, so it will be parallel. Input is this is IF equal to beta times of V naught. Okay, so just compare these two circuits. Only input part is different and output is same. This is same. Just compare these two. Okay, so we are calculating output impedance. So output part is same. So the derivation will be same. The derivation will be same. Excuse me. Okay, so again you can remove the load resistance from the circuit, right? Okay, V is equal to, okay, so V equal to I R naught plus A IA, A into IA. So you just apply KVL. So what will get? V equal to I R naught plus A into IA is nothing but IS minus IF. V equal to I R naught plus A into, so IS is anyway 0 minus IF. So V plus A into IF equal to I R naught. V plus A into IF is what? IF is beta times of output voltage. That is V equal to I R naught. Take V as common, 1 plus B beta equal to I R naught. So P by I equal to R naught by 1 plus A beta. So this is R naught f equal to R naught by 1 plus A beta. See, same. Okay, same derivation. Only thing is input is voltage here, their input is current, but anyway panel meeku వచ్చే output అనేది same. Okay, so this is what the voltage shunt gain. Okay, now I will go with current series. Current series feedback amplifier. Okay, so what is the basic amplifier for current series?
Transconductance.
Transconductance means input is voltage, output is current. So this is the basic amplifier circuit, and it is series now, so it will be series. Vs, Rs, Rl. So A into Va, R naught, Rl. Okay. So what happens? This is input is voltage, no? So Vf, Vf is equal to beta times of I naught. Okay. So for this, again, say when you are calculating output impedance, so load resistance should be disconnected. Okay. So load resistance should be disconnected here. And next one is the input signal. The input signal should be kept constant. Now apply. So now you remove this connection. You remove this connection here. Okay, you remove this connection, and this is I. So I. So these two are entering currents, and this is leaving current. So I is equal to. Okay, I equal to. So what is the voltage drop across this? So V is the voltage drop. Okay, so this current is what? A into VI plus what is the current flowing through this V R naught, that is V by R naught. Am I right? I equal to AVI, I equal to AVI plus V by R naught. So from this I equal to VI is nothing but Vs minus Vf plus V by R naught. I equal to A into minus Vf because Vs is 0 plus V by R naught. I plus AVF equal to V by R naught. So I plus VF is what? VF A into beta times of I. Okay, V by R naught. Take I as common. 1 plus A beta equal to V by R naught. So from this I can rearrange the equation V by I naught equal to R naught into 1 plus A beta. This is R naught F equal to R naught into 1 plus A beta. Okay, so this is the output impedance for current series feedback amplifier. Current series feedback amplifier. Any queries?
No, sir.
Okay, now we try it for next one. We try it for next one. Current shunt feedback amplifier. Try it for current shunt feedback amplifier output impedance. Hello. Hello. Sir.
Yes, sir.
లేదు సార్ నేనే తీసుకుంటున్నాను సార్ ఇది నేను సార్ అవునా సరే అయితే నేను ఒక 1 అవర్ తీసుకున్నాను సార్ ఇప్పుడు 3rd అవర్ మరి మీరు 4 అవర్ నుంచి మీరు కంటిన్యూ చేస్తారా మరి అవును సార్. మీ ఫోర్త్ నుంచి మీరు లాస్ట్ వరకు మీరు తీసుకోండి సార్. ఓకే సార్, నేను థర్డ్ వరకు తీసుకుంటాను సార్. ఓకే సార్. ఓకే సార్. Yes. So try it for current shunt feedback amplifier output impedance calculations. And if you have queries, and please ask. Any queries? Current shunt feedback amplifier. Current shunt feedback amplifier. What is the basic amplifier for current shunt?
Current amplifier.
Current amplifier.
So recall your current amplifier structure. So input is shunt, no? So feedback will be parallel. Yes. I. This is IF equal to beta times of I naught, and this is A into II R naught R. Okay. So this is it. So now this should be disconnected. So output is V. Okay. Apply KCL at this node. By the KCL at this node. I is equal to A into II plus V by R naught. So the voltage current passing through the resistor is voltage by resistor. So I equal to A into II is nothing but IS minus IF plus VA by R naught. So that is equal to A into minus IF. Why? Because IS is 0. V by R naught. I plus A into IF equal to V by R naught here. Okay. I plus A into IF is nothing but what is IF? IF, this is IF. So beta times of I equal to V by R naught. Take I as common. 1 plus A beta equal to V by R naught. So rearrange the equation into 1 plus A beta. Finally, R naught F equal to R naught into 1 plus A beta. Any queries in this? Tell me. Any doubts?
No, sir.
So clear? Okay. Now I will write it on summary. I will write it down for summary. Uh, Summary. Okay. So now voltage series. Voltage current series, current shunt feedback amplifiers. Okay, these are the four types. Okay, so input impedance, output impedance, input impedance, output impedance. So here what will get, write your summaries and what happens to input impedance and output impedance of these four feedback amplifiers. Write it down. Write it. Okay, see, I'm writing. Anyway, it is increased or decreased by factor of 1 plus a beta 1, So I'm just writing here like this, 1 plus a beta. For voltage series feedback amplifier, whether input is increased or decreased, tell me. For voltage series feedback amplifier, input impedance is increased or decreased? Huh?
Increases.
Increases. Okay. Next, output impedance.
Decrease.
Okay. Voltage shunt. Input impedance for voltage shunt input impedance. Huh?
Decreases.
Decreases.
Okay. Output. Output. Voltage shunt output impedance. వోల్టేజ్ అండ్ అవుట్పుట్ ఇంపెడెన్స్కి ఏమవుతుంది?
Decreases.
ఇదే కదా వోల్టేజ్ అండ్ డిక్రీజెస్. ఓకే, నెక్స్ట్ కరెంట్ సిరీస్ ఇన్పుట్ ఇంపెడెన్స్. కరెంట్ సిరీస్ ఇన్పుట్ ఇంపెడెన్స్
Decreases.
increases. Okay, output
Increased.
Increase.
okay. Next current shunt input
Decreases.
Decreases.
okay. Output
Increases.
okay, increase. So from this you can summarize or you can conclude two important points. Only one important point here. Just look at this table. Look at this table. See, increased. Leave about that whether in input impedance and output impedance. Forget about it. Okay, you forget about it. Let's talk about whether it is input or output. Leave it later. Okay, now coming to the four increases are there in the table. Actually, there are eight of four out of 8 increase and another 4 is decreased. Okay, is there any commonality in these 4 increases with respect to your what we call this one feedback amplifiers? With respect to the feedback amplifiers, is there any commonality? Is there any commonality for these four increases? Okay, let me explain. Suppose if you take these two, this is input impedance, so input is series connection, increased, decreased. Okay, am I right? Series connection, input is series connection. So input is series lo undi kabatti input connection, input impedance increase and increase. That is a common. Am I right? Yes or no? Are you there?
Yes, sir.
So for voltage series and current series, input is series connection. So the input impedance of these two feedback amplifiers will be same. That is increased and increased. Now coming to these two, this is output impedances. Output impedance is also increased. Now output impedance until you go to the output parameter. What is output connection? So this is current series, current shunt. Current series means what is current? It's a type of sampling. Sampling is nothing but fixed. I mean constant. Am I right? Current is nothing but constant. So current will be constant in which connection? In series or shunt?
series,
Current ఎక్కడ కాన్స్టెంట్ ఉంది? సిరీస్ లో కాన్స్టెంట్ ఉందా, షంట్ లో కాన్స్టెంట్ ఉందమ్మా?
Series.
Series. So for these two, output is series connections. This is output series connection. For this also output series connection. Okay. So for output is series connection, output impedance is increased. So you can summarize one important point. So what is the summary? If the connection is series connection, then the corresponding impedance will be multiplied by 1 plus a bit. Am I right? So మీకు సిరీస్ కనెక్షన్ ఇన్పుట్ లో ఉండండి, అవుట్పుట్ లో ఉండండి. సిరీస్ కనెక్షన్ ఉంది అంటే ఆ కరస్పాండింగ్ ఇంపెడెన్స్ అనేది మల్టిప్లై అవుతుంది. సో ఇంక్రీజ్. సో ఆర్ నాట్ ఎఫ్ ఈక్వల్ టు ఆర్ఐఎఫ్ ఈక్వల్ టు ఆర్ఐ ఇంటూ 1 ప్లస్ ఏ బీటా, ఆర్ నాట్ ఎఫ్ ఈక్వల్ టు ఆర్ నాట్ ఇంటూ 1 ప్లస్ ఏ బీటా. సో సిరీస్ కనెక్షన్ ఉంటాయి. సో వెదర్ ఇట్ ఈస్ ఇన్పుట్ కనెక్షన్ ఆర్ అవుట్పుట్ కనెక్షన్, wherever the series connection is there, that corresponding resistance will be multiplied by 1 plus a beta. Okay, if input is series connection, RIF equal to RI into 1 plus a beta, series connection is there in the output, R naught F equal to R naught into 1 plus a beta. Understood? Yes or no?
Yes, sir.
Yes, sir.
Next, similarly, second point is what? If the connection is shunt, then the corresponding impedance will be divided, not multiplied, divided by 1 plus a bit. If you see, this is decreased. Now, okay, now look at this. Decreased. Ikkada decrease undi, ikkada decrease undi. Input lo decrease lo undi. Why? Because input connection is shunt. In two cases lo shunt connections, so input is decreased. And coming to this output impedance, this is decreased. Why? Because output is voltage for these two cases. Output is voltage is for these two cases. The voltage will be that is the sampling. Sampling will be constant. That is voltage will be constant in this shunt connection only. So for this voltage series and voltage shunt, output is the shunt connection. For voltage series and voltage shunt, output is the shunt connection. So shunt undi kabatti, so output is shunt. So output will be divided. That is decreased. Clear? So this table is face of your first part, entire feedback amplifier, this table. So ఈ table summary మీకు అన్నిటికి. Okay, so what I told, suppose if you are unable to do the derivation part, I mean, if you have any confusions whether the input impedance is increased or decreased, or how it will decrease or the things, so these 2 points will answer your question. These 2 points will answer your question. You take it any type of the feedback amplifier. By seeing the title, you can tell that input impedance. Suppose if you take current series feedback amplifier, current series feedback amplifier. Current series feedback amplifier, if I ask you people, or if the question is asked in the examination, so derive the input impedance and output impedance of the current series feedback amplifier. Okay, so by seeing the title, you can tell that what is input impedance. So if current series, input is series connection. Okay, input is series connection means input impedance will be multiplied. RIF equal to RI into 1 plus A beta. Next, coming to the output. Output is current. So current will be constant. And so current also constant in series connection only. Current will be constant in series connection. So output is also series connection. So input is series, output also series connection. So input impedance and output impedance will multiplied by one factor 1 plus A beta. RIF equal to 1 plus A beta, R naught F equal to R naught into 1 plus A beta. Am I right? So like that. So if you have any queries regarding that, so these 2 points will answer your question. So whether it is increased or decreased. Similarly, suppose if you have suppose if you take another feedback like current shunt, so otherwise you take voltage shunt. Okay, voltage shunt తీసుకుంటే ఏమవుతుంది? Voltage shunt is input connections. Okay, so anyway, so input is shunt kabatti input impedance will be divide RIF equal to RI by 1 plus A beta. And coming to the output, output is voltage will be constant in shunt. Voltage will be constant in again shunt. So output is also shunt, output impedance also divided by 1 plus A beta. Like that, you can so these 2 points, remember, wherever the series connection is there, that impedance will be multiplied. Wherever the division is there, shunt connection is there, that impedance will be divided by the 1 plus A beta. Am I clear? Any doubts?
No, sir.
Is it clear to everybody? So once again, I am telling you, so this unit you not to prepare and you not to buy hard anything. So easily, and you just practice a half an hour after this completion of my class. So you will remember, and you just note down the logics and how to proceed and all the things in your own words, and you maintain separate short notes, so that at last moment or itself you can refer. So in the just 5 minutes time, so you get to refer all those things. You just again I'm telling you, so this is logic based. You just note down the logics and procedures, how to do derivation, how to draw the block diagram, all those things. So definitely I am promising you. So this is 16 marks will come in the examination, and the 2 marks for the two marks in part A. So 18 out of 18 you can score easy. And of course the B bit will be a problem. So that problem also, that I told some formulas, no, that based on that formulas only you will get the problems. Okay, I'm sure. So 18 out of the 18 marks we will get out of this unit. So very easily. Okay, so this is 18, and the power amplifier also I told some 18 marks and 36. So very easy to understand. Is it clear? Any doubts? Everyone?
No, sir.
Okay. So shall we move to the problems?
Yes, sir.
Okay. So note down the problems on this. Note down the problems. An amplifier has an open loop, gain. 800 and the feedback ratio of 0.05 if the open loop gain changes by 20% due to temperature. Find percentage changing close loop. Okay. This is first problem. Solution. Okay. Solution. So the given data is, see, the open loop gain is nothing but the gain without feedback. Closed loop gain is nothing but the gain with feedback. Ante open loop gain ante A, closed loop gain ante AF. Understood? Open loop gain is A, closed loop gain is AF. So from the question A is equal to 800 is given, feedback ratio beta 0.05 is given. If the open loop gain changes by 20% due to the temperature, ante dA by A equal to 20%, 0.2 is being that dA by A. If the open loop gain changes by 20% means dA by A equal to 0.2. So now we have to calculate closed loop change. Find the percentage change in the closed loop gain. So DAF by AF we have to calculate. Okay. Now tell me, what is the formula for DAF by AF? What is the formula?
dA by A into 1 by 1 plus A beta.
Yes, dA by A into 1 by 1 plus A beta. So dA by A is 20%, that is 0.2 divided by 1 plus 800 into 0.05 or 0.05. So that is equal to how much you'll get? How much you'll get?
(4.8 into 10 power minus 3).
4.8 into 10 power minus 3, na? So that implies that we have to
Yes.
calculate in percentage. So into 100 days, you will get 0.48%. Am I right?
Yes, sir.
DAF by AF equal to 0.48%. Okay. Sometimes in some other problems they will give same formula. They will give these two values. These two they will give, and they may ask you to calculate some A by giving beta value. So same formula. So here, how many factor variables? 1, 1, 2, 3, 4 variables are there in this. So they may give 3, and they may ask you to fourth one. Okay, so same formula. So they may ask you to calculate the fourth one. Okay, and remember, closed loop gain ante AF, open loop gain ante A. Open loop gain is A, closed loop gain is A. So the next problem. The next problem. An amplifier has midband gain of on 20% and a bandwidth of 250 kilohertz. Okay. A bit. If 4% negative feedback is introduced. Okay, introduced. Find the new bandwidth here. Find new bandwidth. Gain. Second bit. If the bandwidth is restricted to 1 megahertz, find the feedback ratio. Find the feedback ratio. An amplifier has midband gain of 125 and a bandwidth of 1250 kilohertz. If 4% negative feedback is introduced, find new bandwidth and gain. Second bit, if the bandwidth is restricted to 1 mega, find the feedback ratio. So see, in the first bit and second bit, feedback beta value is given. They ask you to calculate no bandwidth and gain. In the second bit, the bandwidth is given. Again, they ask you to calculate the feedback ratio. Okay. So for both the bits, formula is same. But in the first bit, feedback beta value is given. We need to calculate bandwidth with feedback. The second bit, bandwidth with feedback is given. We have to calculate the feedback ratio. Okay. So solution, given data, what is the given data? Midband gain. So A is equal to 125. A, open loop gain and midband gain. Bandwidth without feedback is 250 kilohertz. Okay. A is equal to 125. Bandwidth is equal to 250 kilohertz. So first first bit, 4% negative feedback is done. Beta is equal to 0.04. 0.04. So find the new bandwidth and gain. What is the formula for new bandwidth with feedback? What is the
BWF
formula?
with feedback equal to BW into 1 plus A beta.
Yes, BW into 1 plus A beta is the formula. With feedback, BW with feedback equal to VW into 1 plus A beta. Now calculate how much? 250K into 1 plus 125 into 0.04. How much you'll get? How much you'll get?
$1,500K.
Yes, under 1.5 megahertz. Right. Next, gain, new gain. What is the formula? AF is equal to A by 1 plus A beta. What is the new gain? 125 by 1 plus 125 into 3.04.
$20.83.
20.83 20.83 is the answer for AF. And second bit enti BWF is given how much? 1 megahertz is given. If the band, second see the bandwidth, if this bandwidth is restricted to 1 megahertz, find the feedback ratio. The new bandwidth is given. Now beta we have to calculate. Same formula, bandwidth with feedback equal to bandwidth into 1 plus A beta. So this is 1 mega, if this is 250K into 1 plus A is 125 into beta. Now calculate. What is the beta value? Tell me.
Zero point zero two four.
Yes, 0.024 means 2.4%. That implies 2.4%. Okay. Right? So next problem. Problem 3. An amplifier has a voltage gain of 400. Okay. F1 is equal to 50 hertz. Ft is equal to 200 kilohertz. And the distortion of 10% without feedback. Find the voltage gain. Find the voltage gain F1F, F2F, TF. Then a negative feedback is applied. With a feedback ratio of 0.01. 0.01. So note on the problem. An amplifier has a voltage gain of 400. Full stop. F1 equal to 50 hertz. F2 equal to 200 kilohertz. And a distortion of 10% without feedback. Find the voltage gain, comma, F1F, comma, F2F, comma, DF when a negative feedback is applied with a feedback ratio of 0.01. 0.01. Okay. What is the given data here? Given beta is equal to 0.01, A is equal to 400, F1 is equal to 50 hertz, F2 equal to 200 kilohertz, and the distortion D equal to 10%, means 0.01, so 0.1. %, 0.1. So what is F1? What is F2? What is F1?
Higher cutoff frequency and lower cutoff frequency.
What is higher? What is lower?
F2 is higher.
Okay. F1 is lower.
Yeah.
Okay. Now calculate. What is the formula for voltage gain with feedback? AF formula ఏంటి?
A by 1 plus A beta.
Huh? AF equal to what? What is the formula?
A by 1 plus A beta.
A by 1 plus A beta. Okay, substitute and tell me the answer.
Yeah, it is, sir.
80. Okay. Next. F1 F, what is the formula?
F1 by 1 plus A beta.
Yes. What is the answer?
10.
10.
10 hertz. Okay. Next, what is F2F?
F2 into 1 plus A beta.
2 into 1.
Yes, F2 into 1 plus A beta. What is the answer?
Forty into 10 power 3.
Ma? Sorry, F2F ఎంత? Answer please, F2F.
40 kilohertz.
40 na? 40 and Vasu.
Sir, 1 mega.
Yes, 1 megahertz. ఈ వాల్యూ ఎంత వస్తుంది చూడండి, ఇక్కడ ఇది 5 వస్తుంది. ఇది 1 ప్లస్ ఏ బీటా అనేది 5. ఇది ఇక్కడ క్యాలిక్యులేట్ చేస్తే ఏమొస్తుంది? 400/5 into 80, 50/5 into 10, 200 into 5 into 1 mega. What is the DA formula?
D by 1 plus A beta.
A beta.
Okay. What is the answer? What is the answer?
0.02.
0. ఇంతనా? 0.02
Yes, sir.
2%. ఇంతగా? Okay. The next problem. an amplifier with negative feedback gives output of 12.5 volts with an input of 1.5 volts. Okay, and feedback is removed. It requires 0.25 volts to input. It requires 0.25 volts input for the same output. For the same output. Find value of voltage gain without feedback. Without feedback. The value of beta input and output are in phase and beta is real. Beta is real. So this is the formula, fourth problem. Okay. Now what is the given data? An amplifier with negative feedback gives an output of 12.5. Output వచ్చేసి 12.5. With feedback or without feedback, output is output. That is 12.5 volts. Okay. And with an input of 1.5. With feedback input and that is Vs is equal to 1.5 volts. Fine. When the feedback is removed, it requires 0.25 input. Without input, without feedback, what is input? I is equal to 0.25 volts. With feedback input is Vs. Without feedback input is Va. Okay. For the same output, find the voltage value of voltage gain without feedback. Without feedback formula. Without
V naught by VA.
Without A is equal to V naught by Va. This is 12.5, 0.25. How much?
50.
Sorry? 50. Okay. Next, this is A bit. B bit is what? Value of beta. What is the formula for beta? How we can calculate? Beta is equal to what?
VF by V.
Vf by V naught. Am I right? Yes or no?
Yes, sir.
Okay. So in this Vf by V naught, we have V naught value, and Vf how we can calculate? we know that Vi equal to Vs minus Vf formula ఉంది కదా. Yes or no?
Yes, sir.
So from this Vf equal to Vs minus Vi. Vs is 1.5 volts minus 0.25 volts. How much you get? 1.25 volts also. Am I right? 1.25 volts. Now substitute. So beta is equal to 1.25 by V naught is 12.5. How much you get? How much you'll get? 1.25 by
0.1.
12.5.
0.1.
This way you can calculate, and another way also you can calculate, like, or you know A value, you calculate AF also. AF is equal to V naught by Vs. That is 12.5 divided by 1.5. 12.5 by 1.5 అంటే అంత వస్తుందమ్మా. 12.5 by 1.5 means you will get up to 8.33 volts. 8.33. Okay. So from this, AF is equal to A by 1 plus A beta. So AF is known, A is known. So you can calculate beta. Like this also you can calculate. Okay. Like this also you can calculate. Two ways. So directly you can take V beta is equal to Vf by V naught and you can calculate. Otherwise you can go with AF is equal to A by 1 plus A beta. You can calculate. No, two ways you can calculate. Right?
సార్
Yes.
సార్ అక్కడ ఇన్పుట్ అవుట్పుట్ ఇన్ ఫేజ్ అన్నారు కదా సార్, అప్పుడు విఐ ఈజ్
Yes.
ఈక్వల్స్ టు విఎస్ ప్లస్ విఎఫ్ అవుతుంది.
Sorry. ఎక్కడమ్మా?
ఇన్పుట్ అండ్ అవుట్పుట్ ఆర్ ఇన్ ఫేజ్ కదా సార్ ఇక్కడ క్వశ్చన్ లో.
ఓకే.
అప్పుడు విఐ ఈజ్ ఈక్వల్స్ టు విఎస్ ప్లస్ విఎఫ్ అవుతుంది కదా సార్.
ఓకే. Then yes, good point. Yeah, fine. So suppose if it is in phase, okay, so that good observation actually. Okay, in phase. So yes, you're right. So VA equal to VS plus VF, VS plus VF, and this becomes VF is equal to this becomes what? VA minus VF, VA minus VS, and we'll get some negative voltage here. Okay, now so that will get the B beta is equal to negative value. So that is one value. In the coming to this back here, so here you have to take AF is equal to A by 1 minus A beta. In phase and positive feedback, you out of ఇలా వస్తుంది 1 minus A beta. Okay. Now you can substitute and you will get the same value again. Okay. So here the beta you will get a negative value. Here you will get the negative value. Yes, in phase and negative value వస్తుంది. So but so coming to the second procedure, so here you are not supposed to take A by 1 plus A beta. You have to take A by 1 minus A beta. Okay. Right. Correct. In phase అంటే నెగిటివ్ పాజిటివ్ తీసుకోవాలి. VI మైనస్ VS. అప్పుడు మీకు ఇది మైనస్ 1.25 వస్తుంది. మైనస్ అంటే మైనస్ ఇది మైనస్. This is 1 minus negative వస్తుంది. Right. Over. What's your name, madam? Hello. Hello.
అశ్విని సార్.
Okay. Good. Very good. Next, fifth problem. Calculate the gain, input impedance and output impedance. Of voltage series feedback amplifiers having A is equal to 300, Ri equal to 1.5 kilo ohm, R not equal to 50 kilo ohm, and beta equal to 1 by 12. Okay, this is another model. So the gain is for all the types of feedback amplifier, AF equal to A by 1 plus A beta. Okay, so here the A is 300 is given, Ri 1.5 kilo ohm, or not 50 kilo ohms, right? Very good. Beta is equal to 1.1 by 12. Okay, this is the given data. And now calculate the gain for the feedback voltage series feedback amplifier. So AF equal to A by 1 plus A beta, that is equal to 300 by 1 plus 300 into 1 by 12. What is the answer? What is the answer? Hello. Class లో ఉన్నా నేను అర్జెంటా నేను మళ్ళీ వస్తా క్లాస్. Okay, what is answer? Answer please.
Sir, 11.53.
11.53 na? Okay. Next, input impedance with feedback. RIF equal to, what is the formula? RIF, RI ante input impedance. So now see the connection. Input connection enti voltage series feedback amplifier input connection enti.
Series.
beta.
Series means impedance will be multiplied or divided.
Multiplied.
Multiplied.
So RI into 1 plus A beta. RI is 1.5K into 1 plus 300 into 1 by 12. What is the answer? How much? What is the answer?
$39,000.
39 kilo ohms. 39 kilo ohms.
39 kilo ohms. Okay. Next, R naught of formula is R naught F ఫార్ములా ఏంటి? ఆర్ నాట్ అంటే అవుట్పుట్ కదా. సో
Not
వాట్
by
ఈస్ అవుట్పుట్ కనెక్షన్?
not
by
వోల్టేజ్ సిరీస్
R.
ఫీడ్బ్యాక్ యాంప్లిఫైర్. వాట్ ఈస్ అవుట్పుట్ కనెక్షన్? సిరీస్ or shunt?
Shunt.
ఫస్ట్ టర్మ్ ఈజ్ దిస్ అవుట్పుట్ కదా. సో వోల్టేజ్ షంట్ అంటే ఏంటి? ఐ మీన్ వోల్టేజ్ శాంప్లింగ్ అంటే ప్యారలల్, షంట్ శాంప్లింగ్ అని. సో షంట్ ఉంది కాబట్టి అవుట్పుట్ ఇంపెడెన్స్ ఏమవుతుంది? మల్టిప్లై ఆర్ డివైడ్?
Decreases. Divided.
by 1 plus AB. 50k divided by 1 plus 300 into 1 by 12. How much?
1923.07.
1.9
kilo ohms.
kilo. Okay. 92 వస్తుంది. 1.92 kilo ohms వస్తుంది. So this is one problem. And sometimes suppose if they give Rn is equal to some 1.5 kilo ohm, same problem. R naught is equal to 50 kilo ohm and AB is equal to 300 is there, for example. Without mentioning that voltage series or voltage and current series function, without mention, they will not mention all those things. Simply they will give Ri, R naught, AV and is there. Okay. So then AV and into voltage gain. Voltage gain will be there in the voltage series feedback. Like that you have to take it. Right? AV అంటే వోల్టేజ్ గెయిన్. వోల్టేజ్ గెయిన్ అంటే ఏమంటే మీకు బేసిక్ యాంప్లిఫైర్ వోల్టేజ్ యాంప్లిఫైర్ అయి ఉండాలి. సో వోల్టేజ్ యాంప్లిఫైర్ విల్ బి యూస్ ఇన్ ద వోల్టేజ్ సిరీస్ ఫీడ్బ్యాక్ యాంప్లిఫైర్. లైక్ దట్ యూ ట్రాక్ అండ్ టేక్ ద ఫార్ములాస్. సమ్ టైమ్స్ ఇట్లా అడుగుతారు మీకు. ఓకే, ఏవి ఆర్ ఏఐ ఆర్ జిఎం ఆర్ ఆర్ఎం లైక్ దట్. సో సబ్ స్పెసిఫిక్ అట్లా ఇట్లా ఇస్తారు, లైక్ గెయిన్స్ ఇస్తారు వితౌట్ మెన్షనింగ్ ద ఫీడ్బ్యాక్ యాంప్లిఫైర్. దెన్ యూ హ్యావ్ టు టేక్ కరెస్పాండింగ్ ద ఫీడ్బ్యాక్ యాంప్లిఫైర్ అండ్ డూ ద ప్రొసీజర్. Okay. Clear? Any doubts? Respond please. Any queries?
No, sir.
Okay, shall I move to the next topic? If you have no queries, I will move to the next topic. Okay, so this is for feedback amplifiers. Feedback amplifiers. Now I will go to the second part of the fifth module, oscillators. Okay, second part of fifth module is oscillators. Okay, so in this oscillator, we will use the positive feedback. We will use the positive feedback. So whereas the negative feedback is used in the feedback amplifiers, and we are going to use the positive feedback here. Okay. So what is the definition of the positive feedback? If the input signal and output of the feedback network, if both are in series, I mean in phase, if both are in phase, then the feedback is said to be positive feedback. Okay, if both are in phase, then the feedback is said to be positive feedback. So the same block, this is the mixer, this is basic amplifier, this is sampling, this is feedback network beta value. Okay, so this is xs, xi, x naught here, and the beta equal to sorry, so this is xf. Both are in phase. So from here xi equal to xs plus xf. Both are in phase means xi equal to xs plus xf. Okay. Here the beta ratio is beta, so that is equal to xf by x naught. And a is equal to same formula xi by xi, af equal to x naught by xf. Okay. So this is a beta aa af. From this you can calculate af is equal to x naught by, sorry, this is not xf, this is xs. Okay. X naught by xs is xi minus xf. From this xi equal to xs equal to xi minus xf. Take xi as common, 1 minus xf by xi. Next x naught by xi divided by 1 minus xf by x naught into x naught by xi. Af is equal to a by 1 minus a beta. So whereas in the negative feedback you got 1 plus a beta, in the positive feedback we'll get a by 1 minus a beta. Okay, 1 minus a beta. So, and coming to this is the positive feedback concept, and coming to the oscillators. So oscillator is nothing but which is an electronic circuit. The oscillator is an electronic circuit which generates an AC output signal without having its input signal. Okay, so the definition is an electronic circuit which generates AC output signal without input signal is called an oscillator. Okay, an electronic circuit which generates AC output signal without input signal is called an oscillator. Okay, so now why we are using the positive feedback only here? Why can't use a negative feedback? Is so we know that according to the definition there is no input signal. Okay, so there is no input signal means, so what is this? Xs equal to 0. Xs is equal to 0. Why? Because I'm not giving, so but theoretically we are saying that xs signal, but xs is not there, so xs is 0 because for AC for oscillator there is no input signal. So xi becomes xf as xs equal to 0. If xi equal to xf and af af is equal to a by 1 minus a beta. A beta a beta is nothing but x naught by xi into beta is xf by x naught. This is the form. X naught cancel, and xi xf is also same. Okay, so ABF is equal to, you will get infinity, will get. Okay, so with feedback you will get the infinity. So means without input signal also you are getting infinity gain means, but so this is ideal case, but practically you may not get infinity, but you will get some a signal. Okay, so like in terms of volts without having any input signal. Okay, so in the oscillator, so why we are using the positive feedback means we don't have any feedback input signal, so we have to generate our signal on our own. The circuit has to generate the signal, right? So in this actually in this formula, so xs is 0. Why? Because we are not having any input signal. Xi equal to xf. If you substitute here, you will get af is equal to infinity. So now without having input signal, you are getting infinity gain or not. So infinity gain means the output is nothing but some x value will get. So in terms of volts, okay. Uh, so in terms of volts we will get. So therefore, from the for this reason, so we are using the positive feedback for the oscillator. Okay, this is the one. Now the important so this is the one. So the a beta is equal to that is x naught by x into xf by x naught. Everything cancel, we get 1. Loop gain is equal to 1. Okay, so now coming to this the effect of next topic. Now let us see if what is the effect of this loop gain on the output waveforms of the oscillators. Let us see the effect. Okay. Okay, so this is the one. Next, the most important factor is Barkhasan criteria. Barkhasan criteria, most important factor. Barkhasan criteria. So now, the conditions of the oscillation. So Barkhasan criteria, there are the two important points. So the first point is, so we know that I will draw the circuit again, the basic block diagram. Basic amplifier, beta, 1150 cos 1150 50 3 hours ల్యాబ్ ఎవరు ఉన్నారు 1 minute huh? Yes. ఏమో మరి కాలేదు Adores. Okay, so coming to the topic, Barkhasan criteria. So I'm drawing the first the basic building block, basic block diagram. So this is the place. So the dotted line is nothing but excess actually, but excess is not there now. So I'm drawing with the dotted line. So here basically we'll use the CE amplifier only here. Basic amplifier means we of course we have what we have the things like CE, CB, CC amplifiers. But so we'll use only C amplifier. Why? Because which has a good gain, current gain, voltage gain, moderate input impedance, moderate output impedance. Because of the characteristics, we'll use the C amplifier. So if you give the input signal here like this, output you will get it as out of phase like this. So that out of phase signal again you are giving like this. Okay. So in order to the definition, the input of the basic amplifier and output of the feedback network should be in phase. So here also it has to give a signal like this only, then only so this signal and this signal will be added or subtracted, whatever. So both signals should be in phase. So in order to get the both phases in phase, the beta the feedback network also should provide 180 degrees. So therefore it is giving 180 degrees and this is also giving 180 degrees. The total phase shift becomes 360 degrees or 0 degrees. This is the first criteria, broadcasting criteria, that is the overall phase shift. Overall phase shift, okay, must be 0 degrees or 0 degrees or 360 degrees. Clear? So the second point is the loop gain. In order to get the best, so infinite and the maximum gain, the loop gain must be unity. The loop gain must be unity. Okay, the loop gain must be unity. So there are the two important factors. There are two important factors. So one is overall phase shift must be 0 degrees or 360 degrees, and the loop gain must be unity. So these are the two Barkhasan criteria points, two important Barkhasan criteria. Okay, very, very important. So they may ask for the 2 marks, damn sure question for the oscillators, 2 marks question, this is the one. Okay, this is a Barkhasan criteria. Suppose if the loop, okay, overall phase shift must be 0 degrees or 0 degrees or 360 degrees. If the loop equal to unity, what happens? Okay. Effect of loop gain on magnitude of output signal. Okay, effect of loop gain on the sustain. Otherwise I can draw like this. Okay, effect of loop gain. So, for example, if A beta is greater than far greater than 1 or greater than 1 or far greater than 1. Okay, greater than 1. So if it is like this, the output will be decaying type. Decaying ante so this is decaying type. So initially the peak is high. Okay, the next cycle, and the next cycle, so it's go on again. So this we call it as decaying oscillations. Decaying oscillations. Okay, if you are maintaining A beta for greater than 1, so your output will be like this. Your output will be like this. And second case, if A beta less than 1, so is less than 1. Like this. This is what growing type. Growing oscillations. Growing oscillations. Initially, the peak value is small for first cycle, and it will increase for second cycle, third cycle, fourth cycle. It will increase like that. Okay. The next one, third is if beta is equal to 1. This is what actually we require for the sustained oscillations, and ever out like this sustained. So good. So all peak to peak voltages for all cycles are same. Okay. So peak to peak voltages for all cycles are same. If beta, so this is the effect of the loop gain. Okay. So effect of loop gain. Okay. Right. So the next one is classification of oscillators. Classification of oscillators. Classification of oscillators. Okay, so in this classification, mainly LC RC oscillators. Third one is the crystal oscillator. Of course, there are so many, but we have only 3. So out of 3 also we have only 2. So LC oscillators, RC oscillators. In LC, Hartley Colbert's oscillator, RC phase shift oscillator, and this is okay. So there are LC oscillator. There are 2 types: Hartley Colbert's and RC are 2 types: RC and Wesley. So these will called as a high frequency oscillator. High frequency. These 2 are the low frequency. High frequency oscillator, low frequency.